Hello everybody, I am Tahereh Ramezani and today I want to talk to you about an interesting subject. Let me share a screen. Yes. Bohm-Vitense gaps. Today I want to talk to you about what is Bohm-Vitense gaps, who was Bohm-Vitense, and some simulations and conclusion and reference. Maybe you ask me that what is Bohm-Vitense gap means? What does it mean? Bohm-Vitense gaps is a discontinuity in the color of distribution of A to F type of stars. We have different type of stars. From A to F type of stars, we have some discontinuities in color in the main sequence. Convective transport, both in the interior and in the atmosphere, yields a very sharp transition between structures. This produces a sudden change in the T effective of stars. T effective around 6,800 Kelvin. Who was Bohm-Vitense? Erika Helga Raff Bohm-Vitense. She was a very famous scientist, and she discovered she was the first one that discovered these color gaps. And we can see this gap when the stars changes the atmosphere from radiative to convective at T effective around 7,500 Kelvin, or B minus V is around 0.22 and 0.28. There are two possible ways in which convection might alter the color. The first one is in the deep atmospheres, we can see that T gradient is less than radiative gradient. And the second reason is the photospheric granulation associated with convection originates temperature inhomogeneities, which again redden the B minus V. Some scientists like Rockford and Cantorna wanted to re-examine the Bohm-Vitense gap, that whether it is right or not. And they re-examined from 9 open clusters, and in 6 of them, they saw some evidence that there is Bohm-Vitense gap in there. So they saw that, yes, it is true. If we see very small color variation in the clusters, from cluster to cluster, maybe you can see that there is a clue that there is a gap in there, in that cluster. And also we should consider the metallicity, that is important, and that where is the location of the open cluster in the main sequence. And the Hyades, which seems to have the reddest gap, has metallicity somewhat larger than solar. In figure 1, it is about the Hertzsprung-Russell diagram of the Hyades. In figure 1, we can see that from 0.35 to 0.4, there is a gap for FST. We can say that this line is FST, or full spectrum of turbulence. And this the dot dash line is MLT, mixing length theory. And here, these are singular stars, and this is the symbol of variable star. And we can see, as I told you, from 0.35 to 0.4, there is a gap. That FST models show this gap. And also from 0.4 to 0.5, there is a clustering of stars. We say that in this region there is a gap. Why? Because there are just 4 stars in this region. But for example, in this region there are 15 stars. And just in this region we see a gap, that the number of stars are less than the other regions. The authors of this article that I used the new Vienna University model atmospheres, and they computed with FST and MLT models, and they saw that with FST model they can see an evidence for gap, and they saw there is a gap from B minus V less than 0.4. And but they didn't see any this behavior for MLT model. And the stellar structure computed with FSC show a very sharp transition from radiative to convective envelopes. That we said that if there is a gap from radiative to convective envelope, we can say that there is a Bohm-Vitense gaps that we called it. In figure 2, you can see the highest Hertzsprung-Russell diagram is compared with 2 simulations. In this figure, N is 100. That, as I showed you, as you see, it is the highest, and these are 2 simulations. And the number of the stars are 100, that they are randomly. And M is shown the mass, that the mass is around 1.2 and 1.7. We considered number of stars randomly extracted from a Salpeter mass function distribution. And for conclusion, we can say that the gap location and width depend slightly on 4 parameters. The first one, metallicity. The second is age of the studied sample. The third one is mixture of data for different populations. And the last one is evolutionary phases wash out the feature. And this is the reference that I used. As you can see, the Bohm-Vitense gaps, the role of turbulent convection. And thank you for your attention. I hope it was useful for you and you can use it for your future. Yes, and I can now stop sharing. Thank you for your listening. I hope it was useful for you. Thank you. See you later.